Hello students, welcome to EPG Pathshala. I am Dr. Rashmi Sinha from Indira Gandhi National Open University, Delhi. This module is about the basic concepts of human growth from the paper Human Growth and Development in Nutrition. In this module, we'll be talking about growth, development, differentiation and maturation. Let us now see what we are going to learn from this module. We are going to differentiate the term growth, maturation, and development. We are going to understand the basic principles of human growth and development. We will review the distinct patterns of human growth. We will understand the concept of catch-down growth and catch-up growth. And finally, we are going to comprehend the significance of growth studies. We, as an anthropologist, have always been interested in the variation of human across socio-cultural and geographic dimensions. These variations often demonstrate the adaptive responses to the induced environment, which involves the basic patterns of growth and development during different phases of lifespan. Let's see what are the different phases of lifespan. They are the infancy, childhood, adolescence, adulthood. I'm sure majority of you must be adults by now, and then of course, last being the senescence. Thus, it is important to understand these basic biological responses leading to the disparity among human beings. The module would explain the basic biological processes which transform single fertilized egg into a mature multicellular organism. The module would be explaining, right from a single cell, from the single fertilized egg to the multicellular organism, the basic principles and the pattern of growth and the concept associated with deviation from the normal growth. The last section would review the significance of understanding these concepts in relation to human population. Growth. Growth refers to quantitative increase in size of the body as a whole or specific part of the body. British Medical Dictionary defined it as progressive development of a living organism or part of an organism from its earliest stage to maturity with an attendant increase in size. The increase in size is a consequence of assimilation of nutrients into the protoplasm, expansion of cell cytoplasm, and cell multiplication. These cellular processes underlying growth are termed as hyperplasia, hypertrophy, and accretion. Now, what is hyperplasia? Hyperplasia refers to increase in cell numbers through mitotic cell division. Replicated chromosomes migrates into functional and identical cells. Hypertrophy is increase in cell size by accumulation of protein and substrates. What is accretion? Accretion refers to increase in intercellular substances. These bind the cells in complex networks such as collagen. These processes occur simultaneously during growth, but predominance of one another process varies with age and the tissue involved. Now let us understand what is development. Development is the progressional change, either quantitative or qualitative, that leads from an undifferentiated or immature state to a highly organized, specialized and mature state. It is described within two distinct domains, biological and behavioral. Development is the progressional change, either quantitative or qualitative, that leads from an undifferentiated or immature state to a highly organized, specialized and mature state. It is described within two distinct domains, biological and behavioral. Biological context includes differentiation and specialization of pluripotent embryonic stem cells into different cell types, tissues, organs, and functional units. Onset of function in a particular tissue or organ characterizes attainment of complete differentiation, occurs in prenatal life. As we could see in the figure, fusion of sperm and eggs produce zygote. This zygote undergoes division and eventually form blastocyst. This blastocyst has a mass of undifferentiated pluripotent stem cells which have the potential to become different type of specialized cell such as muscle, neuron, blood cell and others. These specialized cells form tissue and organs to carry out specific function in an individual, which includes circulatory, respiratory, neural, body movements, etc. When we talk about behavioral domain, it includes social, cognitive and emotional development, that is, acquisition and refinement of behaviors such as understanding and expression of emotions, perception about others, self-awareness, abstract thinking, learning and reasoning. It depends on the basis of culture in which a child is born and reared. The other parameters of behavioral domain is motor skills development, which relates to acquisition of enhanced proficiency for a specific motor task. These varies from postural control to the coordination of movements. For instance, an infant first is able to hold his head up with the help of his hands, then straight without support. It eventually begins to crawl, walk with support and then independently. It's very important to understand that growth and development are two different terms. Now, what are the differences between growth and development? Growth refers to the quantitative change in physical characteristic of an individual, such as increase in height, size, etc., whereas development implies overall change in form and structure qualitatively for enhanced functional skills. Growth is a part of developmental process. Development in quantitative aspect is termed as growth. Development, on the other hand, is wider and comprehensive term depicting overall change in an individual such as cognitive, emotional, social, acquisition of improved skills, etc. Growth does not continue throughout the life and stops when maturity is attained, whereas development is a progressive and continues throughout the life. The physical change acquired during growth could be measured directly, whereas functional and behavioral changes acquired during development are difficult to measure directly. Now let us understand what is maturation. Maturation is the progression towards the mature biological state, or in other words, process of becoming mature. Maturation level varies with the biological system considered, whether endocrine, reproductive, skeletal, digestive, or immunological. Individuals end up as an adults with fully ossified skeleton, but they reach this stage at different times and attain different adult heights. These variations may be designated to differences in the maturation timing and tempo of associated biological systems considered, whether it is again endocrine, reproductive, skeletal, digestive, or immunological. We have learnt about growth and maturation, but then we need to understand the basic difference between growth and maturation. Growth focuses on size attained at a given point in time, whereas maturation focuses on progress in attaining adult size and maturity. However, both processes must be viewed as dynamic cellular processes which target achievements of mature adult state from conception state. The endpoint of maturation is the attainment of functionally mature individual who is able to successfully procreate and raise offsprings. The children of similar chronological age may differ by several years in their levels of biological maturity. Let's take an example. Among the girls who are 12 years old, some are sexually mature while others will mature in next several years. Growth, maturation and development occur in a time frame. They are measured at a single point of time or several points over time. These variations may be designated to differences in the maturation timing and tempo of associated biological system considered, whether they are endocrine, reproductive, skeletal, digestive, or immunological. Timing. Timing refers to when a specific maturational event occurs, for example, age at appearance of pubic hair in boys and girls, or age at maximum growth during adolescent growth spurt. Tempo refers to the rate at which maturation progresses. Now we would discuss the basic principles which underlie growth and development. First one is cephalocaudal and proximodistal development, which explains the direction of growth in an individual. The cephalocaudal refers to the development proceeding from head to toe. In an embryo, the head is approximately half the total body length. However, by the time of birth, the proportion of the head is reduced to approximately one-third of the total body length and becomes further reduced as the limbs and trunk grow increasingly faster. In terms of motor skills, the infant shows voluntary control of the head and shoulders before control of lower limbs. Proximodistal development proceeds from the center of the body to the periphery. For instance, infants acquire control over the muscles of the neck and trunk before coordination of the hands and figure. Although each child follows a general pattern and sequence of growth and development, the rates at which individual child reach various developmental stages will be different. There are interspread periods of great intensity versus plateau. From birth to early adulthood, both stature and weight shows a rapid gain in infancy and early childhood, steady gain during middle childhood, rapid gain during adolescence phase, and slow increase until growth ceases with an attainment of adult stature. A marked individual differences is observed due to age and sex of children. For instance, during early adolescence phase, girls are taller and heavier than boys due to earlier growth spurt. But as the boys attain adolescent growth spurt, they catch up and eventually suppresses girls in body size. Furthermore, the rates of development across the different domains also may be not uniform within an individual child. Some children will walk at 10 months, while others walk a few months older or at 18 months of age. A child's intellectual development may progress faster than his emotional or social development. Let us understand the basic principles of growth and development. The next principle defines development as a continuous process. Development is continuous, predictable process which includes the physical, motor, and behavioral development in early life, leading the child to maturity. Change is continuous even after maturity has been attained and progresses to senescence and death. It follows a sequential pattern where initial phase of growth and development lays foundation for the next phase. As a child develops, new skills acquired become the basis for further achievement and mastery of skills. For instance, there is a predictable sequence of development that occurs before walking. The infant learns to stand by holding onto furniture and then eventually walk alone. Children learn to hold a pencil and crayon before they write or draw. Development proceeds from general to specific. As we see, the infant's movements are very generalized, undirected, and reflexive initially, such as waving arms or moving the whole body. But later, in response to physical or motor development, they become capable of making specific responses or move towards an object. The infant grasps an object with the whole hand before using only the thumb and forefinger. Now, why it happens so? It's because development in the large muscle movements to more refined muscle movements. Let us understand the distance curve. Till now, we have discussed the basic terminologies and principles related to growth, development, and maturation. Now, we need to understand the graphs which could be used to study the growth pattern of an individual. It is obtained when measurements taken at specific intervals are plotted against time. It would provide an estimate for the total amount of growth achieved. For instance, if a child is measured every year till the age of 18 years, then the graph plotted by joining up these data points would provide a line representing the growth achieved at a given moment or at successive time periods. These graphs, in which the measurements are plotted against the time or chronological age it was taken in, as called distance curve. For example, height gained for a given age reflects how far the child has progressed towards adulthood. However, the growth is not a linear process as we do not gain the same amount of height each year. An apparent change in rate of growth is associated with each stage of development. The curve representing the variation in the rate of growth with time is known as velocity curve. Development is an interrelated process: genetic, environmental, and behavioral. The genes determine the potential of a child to achieve optimal development, but is influenced by the socio-cultural and physical environment. Maturation, referring to the sequential development of cognitive and motor skills over time, interacts with child's experiences in a given environment, leading to overall development. A baby cannot feed itself until he or she can sit up and develop the ability to grasp the things between the fingers and the thumb. The speech development of a child is affected if the child has difficulties in hearing clearly or if no one talks directly to him or her. Thus, the development of children to their potential requires support and guidance from the others in their lives. A child who does not receive love and attention may fail to grow in development. Abstract thinking and social behavior during the process of maturation develops according to the peer and family environment they share. In 1930, Richard Scammon proposed that the growth of different tissues and systems could be summarized in 4 patterns. Now, what are Scammon growth curves? The general curve describes the growth of body as a whole and most of the system of body, including skeleton, respiratory, digestive, urinary, and circulatory. In circulatory, we will include heart and blood vessels. The sigmoid or S-shaped curve represents 4 phases of growth. They are rapid growth in infancy and early childhood, then steady but constant growth during middle childhood, a rapid growth during the adolescence, and slow and eventual cessation of growth after adolescence, which continues into the 3rd decade of life. Neural curve characterizes the growth of brain, nervous system, and associated structures such as eyes, upper face, and parts of skull. These tissues experience rapid growth in early postnatal life so that about 95% of total increment in the size is attained by the age of 7 years. After 7 years, the neural tissues show steady gain with slight growth spurt during adolescence. Reproductive curve illustrates the growth pattern of primary and secondary sexual characteristics. Now, what are the primary reproductive characteristics? They are the ovaries, uterus in females, and testes and seminal vesicles in males, whereas secondary sexual characteristics include the breast in females, larynx in male, pubic hair, and others. These tissues show slight growth in infancy followed by latent period during childhood and a rapid growth and maturation during adolescence. Lymphoid curve. The lymphatic system, which includes thymus, tonsils, and spleen and lymph nodes, act as circulatory system for tissue fluid and develop immunological capacities. The lymphoid curve demonstrates a rapid growth until the early adolescent years. Later, it declines perhaps as a result of the activities of sex hormones during puberty. Let us understand the patterns of human growth. After being familiar with the type of growth curve, we would now study the basic pattern of growth. The non-human organisms share the basic sigmoid curve of growth characterized by a single peak. Now, sigmoid curve is S-shaped. The initial period of maximum growth rate or acceleration is followed by a period of deceleration in growth rate. The usual sigmoid curve is modified in case of human and is marked by 2 sigmoid curves, one in early life, the infant phase, and the other in adolescent phase. They are separated by period of relatively slow growth rate during childhood. A rapid growth during childhood, known as mid-growth spurt, is also observed but is not a universal phenomenon. This curve represents the general growth pattern of an individual, but different organs have their own pattern of growth. We are going to learn about catch-up and catch-down growth in canalization. At conception, an individual obtains a genetic blueprint which determines the potential for achieving adult size and shape. In an unconstrained or neutral environment, individual would exhibit a pattern of growth that is more or less parallel to the genetically predetermined trajectory. This phenomena was described as canalization or homeostasis by British genetist C. H. Waddington. However, none of us has lived or been brought up in completely unconstrained environment. During the prenatal and postnatal life, we are exposed to an array of adverse environmental factors which influence the growth velocity, such as disease, malnutrition, etc. In canalization, we'll be learning about the catch-up and catch-down growth. Now, what is catch-down growth? When growth slows down or in more severe cases ceases, it is known as catch-down growth. The amount of deviation from the predetermined pathway depends on the frequency, duration, and severity of exposure to the environmental factors. Slight exposure for short duration will cause minor change in growth velocity as compared to considerable exposure for long duration. The extent of influence is also determined by age and gender of the individual. However, when conditions improve, these exist an ability to stabilize and return to a predetermined growth curve. During such recovery phase, initial growth velocity is above that of normally expected for children of his age or even of his skeletal maturity and decline as the child recovers. This rapid increase in growth velocity following a short-term period of starvation or illness was termed as catch-up growth. Catch-up growth may completely restore the scenario to normal, or it may be insufficient to do so. If it is incomplete, the individual does not achieve the same adult height that would have been achieved when there was no growth impairment. This depends on the extent to which conditions are optimized during recovery. What are the patterns of catch-up growth? Tanner has described distinguished temporal pattern of catch-up growth following pre- or postnatal growth restriction. Type A pattern is characterized by transient increase in growth velocity until the deficit is eliminated, followed by normal velocity when the normal growth curve is achieved. Such patterns are common in infancy and childhood when a child recovers from starvation or illness. Type B pattern shows a growth at low velocity but for a longer duration, which may extend beyond the usual age with a delay in the onset of puberty. When we say that growth pattern is influenced by environmental factors, we need to understand that there are phases of development when environmental exposures have long-term biological and behavioral consequences than at other times. These consequences would eventually influence the health potential of an individual in a favorable or unfavorable direction. The chart reviews crucial stages in human development from fertilization through birth. It focuses on the prenatal developmental stages during which children may be particularly sensitive to exposure to agents or may be at risk of adverse effects that would not occur if exposure occurred during adulthood. Identifying these critical periods is essential to developing strategies that protect children from adverse health effects associated with environmental and non-environmental exposures. Why do we study these phenomena? Growth, development, and maturation. Human variability is one of them. An array of environmental factors, which could be nutrition, disease, physical activity, and others, interacts with the genetic potential of an individual during the years of growth and maturation. This results into a wide range of inter- and intra-population variation through differential rate of growth of particular parts of body relative to others. Understanding these biological variations in terms of origin and distribution among different populations underlie the significance of conceptual knowledge of these phenomena. Health status. The assessment of growth and maturity at periodic interval monitors the health and status of a child and identifies deviation from normal growth, if any. When compared with the healthy children of same age and sex, it indicates the overall health and nutritional circumstances in a community. This approach is often used in the context of nutritional status and general health surveys. Growth progress from childhood to adulthood. The measurement of children at specific intervals of time provides an estimate for the rate of growth and maturation. It estimates the level of biological maturity for the child's chronological age, whether early, late, or average. A child who grows 5 centimeters over a period of 1 year has a growth rate of 5 centimeters per year. The measurements over time on the same individual trace the constancy in the growth indicators from childhood through adolescence to adulthood. Several studies have predicted the tendency of overweight adolescent to become overweight adult by measuring or observing similar individual over a period of time. However, several factors may influence the prediction, which includes interval between measurements, age at first observation, timing and tempo of adolescent spurt, significant environmental change, and measurement variability. Physical activity and performance. Regular participation in physical activity is presumably necessary for optimal growth and maturation of a child. However, to evaluate and recognize the potential effect of physical activity and understanding of normal process of growth and maturation is important. Also, the performance of an individual is influenced by the growth and maturity status. Among boys of the same age, those who are biologically mature tend to be taller, heavier, and stronger than boys who have not matured. Muscular strength is related to the body size, and it provides an advantage to athletes in variety of sports such as gymnastics, divers, etc. Evolution. Over a period of time, humans have evolved morphologically and physiologically to adapt to the surrounding environment. The evolution of morphological characters is the consequence of alternations in the inherited pattern of human growth and development. Thus, the study of growth is crucial in elucidating the mechanisms of evolution. Finally, let us summarize what we have learned in this module. An individual in its lifespan grows to its genetic potential in unconstrained environment, biologically as well as behaviorally, with proficiency in motor skills at different rate and timing. Thus, understanding the basic biological phenomena, growth, maturation, and development is important to evaluate the biological variability, health status, physical performance of an individual or a community.